All right, so I want to talk about Ernest Rutherford. So Ernest Rutherford was one of the understudies of J.J. Thomson, right? And Ernest Rutherford was another person that was just kind of like super brilliant. One of his students or one of his understudies ended up proving him wrong and going on to win a Nobel Prize too. I'm going to talk about him later. All right, but Ernest Rutherford, let's just kind of watch his experiment. Now, during this time, radiation was already kind of being discovered. So, like X-rays, gamma rays, and then there was like other type of radiation. There's three types of radiation that they had discovered. There's alpha, beta, and gamma. All right, and we'll talk about alpha, beta, and gamma radiation a bit later on. But just think of it as waves of energy, right? Just energy. All right, so it's emitted through nuclear power, through nuclear sources. All right, let me see if I can. All right, so there is an alpha particle emitter. So some radioactive material is inside this lead block, and it's going to be allowed to release some radiation. And it's supposed to hit this sheet. And this sheet right there is supposed to act as a filter. It's supposed to block off some of that radiation, so like a little bit less can go through, and then a little bit less gets blocked, or a little bit more gets blocked off from here, and then the rest comes out through here, and then finally to go through the gold foil. Now, gold is has a heavier atom. It's a bigger nucleus. Well, they didn't know about nucleus yet, but it's a heavier substance. They didn't know about it yet, I guess. I mean, they don't know about the nucleus. They will after this video. All right, so the radiation goes through. How do I fast forward this? So there's some radioactive material. It sends out these alpha particles, and then acts as a filter, blocks some of that radiation, and that blocks some of that radiation. Now it's small, and this circle around here is a detector. It detects your radiation. So when the beam goes through, what Rutherford expected was the beam to just go right through like how it did normally. And he expected some of these to get maybe slightly deflected because of the interference with the gold. But what happened was a little bit crazier. That the bouncing back of the bouncing back of the radiation is what led to the next major discovery. So the radiation would go through, and some would get deflected like pretty like sharp angles. The anomalies of anything are usually the most important things to study because they give you information that you weren't expecting. So if you have a model, if you have an expectation and something is off, being able to explain why things are off are really good. I'm sorry, Pika, but please don't step on the keyboard. Please don't knock over the mouse. Let me sit you down over here. Oof. You guys want to see Pika? She's a cute cat. Alright, but anyways, Pika, let's watch this video. So the radiation that's bouncing back is the most important. What that told us, what that told Rutherford was that there must be something inside that's making things bounce back. Alright, so J.J. Thomson's model, where did I draw the cookie? Alright, whatever. But J.J. Thomson's model doesn't seem to hold up. It doesn't seem to match that explanation. If you shoot a beam, it should just go right through it. Now, right here, that deflecting, right? There's a lot of information you get from here. One, it tells us that that sheet of gold foil is mostly empty space if everything can go through. And then number two, if things bounce back sharply, that means there's something heavy in there. All right, it means there's something heavy in there that is making things bounce back. And that right there, that's the nucleus. That's what Ernest Rutherford came up with. He said that there's something super, super massive and super dense that's very, very small in the atom. And he called that the nucleus. He said that is where the positively charged particle is at. That is where the proton is at. So Ernest Rutherford discovered the proton. He discovered the proton, and he said the existence of the proton explains the sharp angles, the radiation being deflected at sharp angles, or the beam of electrons, or the beam of alpha particles being deflected at sharp angles because they hit something super dense with a positive charge. Like if these have a negative charge and they get reflected, there must be something positive in there, and it must be heavy. Those are some of the conclusions he came up with, and that kind of, won him the Nobel Prize. Big deal. I don't know about you guys, but where I'm from, that's a big deal. Where I'm from. All right, but here we go. These are the things. Positive center and the nucleus, and it has a lot of empty space. All right, now we're gonna get into the more accepted model of the atom. Right now, the atom looks kind of like this. It's got it's got electrons embedded into it, but there's something small in there that's positive. All right, so there's positive particles and negative particles. Later on, I believe James Chadwick developed the idea of the neutron. The neutron was a neutral particle with the same charge as the proton, and they were in the same place. So the protons and the neutrons were both found in the exact same place. So when they did calculations, the mass of the nucleus kept coming up twice as high. So it didn't make sense to have 2 times the amount of particles. So there wasn't 2 times the amount of particles of protons. If I'm not mistaken, I might be mistaken. I'll probably be mistaken. I'm for sure mistaken. But yeah. So the neutrons have the same mass as protons. They're exactly the same except for the charge. Protons actually undergo this type of decay that end up becoming neutrons. So they release some energy, they lose their charge, and they become neutrons. But we're not learning that in chemistry. That's more physics stuff. But it's just something that happens, and it's something that's pretty neat to know about. But now we have that general understanding of the electron, right? Soon the idea of the atom will be complete, and I'm sure you guys have seen what I'm drawing here. So these beams were seen as electrons, and then the center was where the protons and the neutrons were at. So you use P with the plus sign for protons, E with the negative for electrons, and then N with a knot or the little circle, a 0, to show that there's no charge. It's neutral. So this idea of the atom is what's next, and then there's the more modern idea of the atom after that, okay?